the Laplace transform of derivatives. So how can you calculate the Laplace transform of the given derivative function? So suppose here the Laplace transform of f of t, that is equal to capital F of s, then the Laplace transform of f dash t, this is equal to s into f of s minus small f calculated at this point 0. So this is the formula. And moreover, in general, the formula to calculate derivatives, that is equal to the Laplace transform of t to the power the Laplace transform of the nth derivative of the function. So the nth derivative of this function f of t, this is equal to s raised to power n, the Laplace transform of f of t minus s raised to power n minus 1, small f of 0 minus s raised to power n minus 2, f dash of 0 minus so on, minus f raised to power n minus 1 calculated at the point 0. So this is the formula. Now here you should note that this capital F of s, that is the Laplace transform of this function, and this small f of 0 is the value of this function whose Laplace transform is given, calculated at the point t is equal to 0. So this is the formula. And next here, what is this? This is the value of f small f given function calculated at the point 0. This is the derivative for this given term calculated at the point 0, and this is the n minus 1th derivative of this given function calculated at the point 0, right? So this is the formula. So moving ahead, let us try to prove this thing. So for the proof, let us see. We will first calculate the Laplace transform of this derivative function. So this is equal to, by definition, integration from 0 to infinity, the value of function, so that is given to be f dash t into e to the power minus st dt. So here what we can do, we have to perform this integration, so we can call this as the first function, this as the second function. Why? Because its derivative is given to you, so its integration is quite obvious. So it would be first function as such, then the integration of f dash t is f of t, and the limits here varies from 0 to infinity, and then minus integration 0 to infinity, derivative of first quantity with respect to t, so it would be minus s e to the power minus st, and then the integration of this second term, so it would be f of t dt. So this is what we got, and here when you substitute t as infinity, so this term would be e to the power minus infinity, so it will become 0. So we would have 0 here, and when you substitute 0 here, you would have minus e to the power minus s into 0 f of 0. So this is the value of first term, and for the second term you would have plus s would come outside, and this is what 0 to infinity f of t e to the power minus st dt. This is nothing but the Laplace transform of the function f of t. So you see this become s into f of s, and here we have e to the power minus 0, that is 1. So we have minus f of 0. So from here we obtain that the Laplace transform of f dash t, that is nothing but s f of s minus f of 0. So this is what we got from here. So next we will perform this property again on the second derivative. So that means we have this property. So now instead of f of t, your function now is f dash t. So in that case, the Laplace transform would be the Laplace transform of this second derivative, and it would be equivalent to s into the, what is this f of s? So let me write it like this first. So this is the Laplace transform of f dash t. This is s into f of s is the Laplace transform of f of t. minus f of 0. So if I replace f of t with f dash t, so what do I get from here? So see carefully, what do I have? I have the term as the Laplace transform of f double dash t. So this is equal to s, the Laplace transform of f dash t minus f dash of 0, right? And we have just calculated its value. What is this? This is this quantity. So let me substitute it here, s multiplied by s into f of s minus f of 0 minus f dash 0. So now you can open up this bracket. So it would be s square f of s minus s into f of 0 minus f dash of 0. So this is the Laplace transform of f double dash t. So this is what we were trying to prove. So again, if you open up this bracket, so you would have the Laplace transform of f triple dash t. It would be s cube, the Laplace transform of f of t minus s square f of 0 minus s f of 0 minus f dash of 0. And then you have Laplace transform of the fourth derivative for this t. So that would be s raised to power 4, the Laplace transform of f of t minus s cube f of 0 minus s square f dash 0 minus f into f double dash 0 minus f triple dash 0, and so on. You keep on doing this. So what we do? We keep on doing this. So finally we reach at Laplace transform of the nth derivative of t. So what would be this? This would be generalizing. So if you have the fourth derivative here, you would have the power 4. So we would have s to the power n, the Laplace transform of f of t, and then the power of s, they go on decreasing. So power 4, power 3, power 2, power 1, power 0. So we would have minus s raised to power n minus 1. The next term would be f of 0, and then minus s raised to power n minus 2. The next term would be f dash 0, and minus so on, right? So the last term would be f the n minus 1th derivative of this term calculated at 0, because if you have the fourth power here, so this fourth power would lead to the last term as the third derivative of this function f calculated at 0, and here the nth power would lead to n minus 1th derivative calculated at this point 0, right? So this is the formula that you have. So we can quickly see one question. So the question here is, find the Laplace transform of the derivative. For the derivative, what would be the question?